Why can a creature with 8 legs and no ears hear the world better than us? Think about it. If you and I lost our hearing, silence would swallow the world. But for a spider, silence doesn't exist because its entire web is a listening device. A spider doesn't just build a trap for flies. It builds a giant sensor, a stringed instrument, a radar dish, all woven into one delicate net. The crazy part? Every vibration that travels through those silk threads is turned into information the spider can read with its legs. For us, ears convert sound waves in the air into signals for the brain. For a spider, legs convert vibrations in the web into signals for survival. This is the story of how a creature without ears has found a way to hear the world. At first glance, a spider's web looks fragile, even disposable. A breeze can tear it. A broom can wipe it away in seconds. But zoom into the silk itself and you realize it's one of the strongest materials in nature. Stronger than steel by weight, but more importantly, sensitive. The thin threads act like guitar strings tuned to different frequencies. When something touches the web, the entire structure doesn't just shake randomly, it sings. And the spider standing in the center is like a musician with their hands on the strings, except the song is telling them who is visiting: friend, prey, or predator. Now here's the first paradox. Spiders don't have ears, but they are master listeners. How? The trick lies in their legs. Each leg has tiny hairs and special sensors that act like vibration detectors. Think of them as miniature microphones built into the limbs. When a fly lands on the far edge of the web, it sends a pulse through the threads. The spider feels that pulse instantly. If you pluck the top string of a guitar, you can hear the note. The spider doesn't hear a note, it feels a pattern. The speed of the vibration, its rhythm, its intensity, all of that is translated into meaning. But here's where it gets even more magical. Spiders don't just feel vibrations, they shape them. Scientists have found that some spiders tighten or loosen their webs like guitarists tuning strings. By adjusting the tension, they change how signals travel. A tighter thread means faster, sharper vibrations. A looser thread means slower, softer ones. In other words, the spider is both the musician and the sound engineer. Imagine if your living room floor was made of piano strings, and you could adjust their tension with your hands to improve the way footsteps sounded. That's what a spider does every day. So let's break it down with an analogy. Imagine you're blindfolded in a dark room. In one corner, someone drops a marble. You don't see it, but the marble rolls across a floor covered in stretched wires. You place your hand on one of those wires and suddenly you feel the faint pulse as the marble crosses. If you've trained yourself, you know not just that something moved, but how heavy it was, how fast, and where it came from. That's the spider's reality. Its web is the wire-covered floor, and every touch is a message. There's another layer. Different vibrations carry different meanings. A struggling fly thrashes with rapid, chaotic pulses. A falling leaf produces a softer, irregular tremor. A potential mate tapping on the thread sends a rhythmic pattern almost like a knock on a door. The spider decodes each of these like reading Morse code. The astonishing thing is that spiders can even ignore noise. They know the difference between the wind shaking the web and the flutter of actual prey. In human terms, that's like standing in the middle of a crowded stadium and instantly recognizing your friend's voice calling your name. Now here comes the eureka part. A spider's web isn't just a trap, it's an extension of its nervous system. Think about that. For us, nerves are inside the body. For the spider, nerves extend into the environment through silk. It doesn't just live in its web, it becomes the web. In scientific terms, this is called an extended phenotype. The spider's body and behavior are fused with its creation. It's like if you could plug your brain directly into a house and feel every knock on the walls, every vibration of the floorboards. You wouldn't just live inside your home, you'd be your home. That's how intimate the spider's connection to its web is. And here's something wild. Some researchers believe spiders actually tune in to specific frequencies that matter most to them. Imagine having noise-canceling headphones, but instead of blocking sound, they block unimportant vibrations. The spider sharpens its attention on prey-sized signals while ignoring the background hum of the world. That means its perception is not just raw detection, it's selective, filtered, and optimized. Evolution has turned a simple silk net into a sophisticated sensor system. Now let's step into the lab for a moment. Scientists have recreated spider webs with lasers to measure how vibrations travel. What they found is astonishing. Vibrations can ripple across the silk like waves in water, bouncing, splitting, and even echoing. Some threads act like express lanes carrying signals straight to the spider. Others dampen the noise like soundproofing foam. Together, the web works like a custom-built soundboard, channeling useful information and muting the rest. It's a piece of living engineering that rivals our best microphones or seismographs. Let's use a metaphor you can feel. Imagine a giant harp stretched across your backyard. Every time a bird lands, a squirrel jumps, or even the wind gusts, the harp sings. Now imagine you can't see or hear, but by touching the strings with your hands, you instantly know what's happening. The size of the bird, the speed of the squirrel, the direction of the wind. That's exactly how a spider experiences life. Its world is a constant concert of invisible signals, and every leg is a finger pressing down on the strings of fate. The practical brilliance of this system becomes obvious when you realize how energy efficient it is. Human ears are complex organs powered by biology. Microphones need electricity, but a spider's web costs almost nothing. The spider spins it, sets it up, and then waits. The silk does the sensing for free, powered only by physics. That's why scientists studying bio-inspired technology look at spider webs as models for future sensors. Imagine bridges that can feel cracks forming by detecting tiny vibrations, or wearable fabrics that act like sensitive microphones without electronics. The spider has already solved problems engineers are still struggling with. But the most poetic twist is this: spiders don't just listen to the world through their webs, they also talk through them. Courtship, for example, is done with vibrational messages. A male spider plucks the threads in special rhythms, sending signals like a coded song. To the female, these rhythms say, "I'm not food, I'm a potential mate." It's communication through music woven into architecture. So the web is not just radar, it's also a telephone line, a violin, and a diary, all strung together by silk. When you think about it, that transforms how we see a spider web. We often walk past them, annoyed, brushing them aside. But really, every web is a living instrument. The spider doesn't need ears to hear. It doesn't need eyes to always see. It simply listens with its legs, translating vibrations into knowledge. And in that moment, the ordinary becomes extraordinary. Here's a twist you might not expect. Spiders can actually remodel their webs not just for strength, but for communication. Some species rearrange or rebuild parts of the silk, almost like changing the strings on a guitar to play a different melody. By doing this, they don't just passively listen, they actively shape the acoustic landscape of their lives. Imagine being able to rewire your ears depending on what sounds you want to focus on today. That's what spiders do, but instead of ears, they use silk and legs. And this brings us to the heart of the matter. Webs are more than tools. They are instruments of perception. A spider without a web is half blind and half deaf. With a web, it's a creature tuned into a universe of hidden signals. This idea, using the environment as an extension of your body, isn't unique to spiders. In fact, it's something humans are starting to rediscover. Think about a blind person tapping a cane on the sidewalk. The cane vibrates back, sending information about obstacles. The brain quickly adapts so that the end of the cane feels like the tip of a finger. The spider has been doing this for millions of years, except its cane is a finely tuned net spread across space, always active, always delivering signals. You might walk past a web and see nothing but threads. To the spider, that's a living map, a soundboard, a sonar array. It's an entire sense organ stretched outside the body. And here's another amazing detail. Spider silk itself is special. Each strand is so fine that vibrations travel through it with incredible fidelity. In experiments, scientists have sent tiny pulses down artificial webs and found that the silk transmits information better than many of our man-made fibers. This means the web doesn't just pass along vibrations, it preserves the details, like a high-definition audio cable. The spider's legs are then the speakers that play the track. That's how they can tell whether a vibration came from a fly, a leaf, or even another spider stepping onto the web. Now let's pause for a what if. Imagine if we humans could do the same thing. Imagine if our houses weren't just shelters but giant sensors tuned to every knock, every breeze, every subtle shift. Imagine if walls could transmit information directly into our fingertips, giving us a live feed of the world outside without cameras or microphones. That's the scale of genius nature built into the spider. We spend billions of dollars on sensors and smart devices. The spider spins a bit of silk and gets a fully integrated alarm system, communication network, and instrument in one. The really mind-blowing part is that this system works on multiple timescales. A fly thrashing in the web produces vibrations lasting seconds, but larger environmental vibrations, like wind or footsteps, can send longer waves. The spider interprets both. Short, rapid pulses mean immediate action. Long, gentle oscillations might just mean weather. In this way, the spider is like a radar operator, filtering through blips on the screen to find the ones that matter. Except it does this without a brain the size of ours. It does it instinctively through the physics of silk and the biology of touch. Think about the elegance of that solution. Humans rely heavily on vision and sound. Spiders can't see very well and they don't have ears. But instead of being handicapped, they turned weakness into strength. They took the medium of silk and transformed it into a sensory organ that doesn't just compete with our hearing. It outperforms it in some ways. You and I can't tell if a sound came from the left or right unless it's relatively close. A spider can detect where a vibration started on its web with pinpoint precision. It's as if they're always sitting in the sweet spot of a surround sound system, perfectly balanced. This is where we hit the Eureka moment. A spider's web is not just architecture, it's biology turned inside out. It's an ear without an eardrum, a radar without electronics, a musical instrument without a musician. The spider is both the player and the listener, both the architect and the tenant, and the payoff is survival. By turning silk into a sensory tool, spiders gained a massive evolutionary advantage. They can conserve energy, detect threats, communicate, and capture food, all with the same structure. It's like carrying around a Swiss Army knife that also happens to be your nervous system. So next time you see a spider web glistening in the morning light, resist the urge to brush it away. Instead, picture what it really is: a giant listening device, a piece of living technology older than humanity itself. Every tremor, every quiver, every ripple across those threads is a message in a language we're only beginning to decode. What looks like fragility is actually resilience. What looks like silence is actually a symphony. And here's the final thought to carry with you. We often look at technology as something humans invented. Microphones, seismographs, antennas. We think they're our creations, but nature beat us to them. The spider web is a microphone woven by instinct. It's a seismograph stretched between branches. It's an antenna waiting for signals. The more we study it, the more we realize our inventions are echoes of nature's designs. In that sense, every spider quietly reminds us, the world is already full of brilliant engineering. We just need to learn to see it. So the next time you pass a web, imagine it not as a sticky trap, but as a finely tuned instrument humming with hidden information. The spider is there, not listening with ears, but feeling with legs, decoding a world we mostly miss. And if that shift in perspective sparked even a little awe in you, then you've just tapped into the joy of discovery. The joy of realizing that even the smallest creature carries a secret key to understanding the universe. That's exactly what we explore here at How It Actually Works. If you want more of these keys, more ways to unlock the hidden mechanics of reality, make sure to like this video, share it with a friend who loves surprising science, and subscribe to How It Actually Works. Because the more keys you collect, the more of the hidden world you'll open. And who knows, maybe the next one will change the way you see everything around you.